Hello, 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 hello. We should be live, I think. Need to double check that. Gosh, phone is blowing up. Alright, looks like we're live. Alright. Okay, I guess let's just jump right into it. This is a follow-up to yesterday's stream where we started looking into the model context protocol. Protocol. So yeah, the model context protocol, and we started looking at the code base for that. I think specifically we looked at the what did we look at? The servers repo, where they actually have some server implementations. I think we even looked at one of the PLs and we made a quick comment about it. It does seem like they have a backlog of PRs coming in, because obviously this thing is attracting can't speak, attracting a lot of attention, and so I'm sure there's a lot of people who have their specific use cases, and they're running into some issues or whatever, and so there's a lot of things being submitted and having a pull request and all that. Anyway, so for today, I think what I want to do is just to really maybe go through one of the SDKs. I'm not sure if I haven't decided whether I want to do the Python or the TypeScript one just yet. I mean, I don't think that it matters much, or at least it shouldn't, right? I guess this being a an AI thing, and Python being such the language of choice for a lot of these AI processing stuff these days, maybe I should just go with that. So this was updated 9 hours ago. The TypeScript one was updated last week. In terms of issues, this has 53, pull request 21. Okay, this has more issues and about the same number of issues. Pull requests. So even by looking at the activity board, I don't know, it seems like the TypeScript one is not as active as a few others. Debugging too. Okay, I guess let's just maybe go with the Python one. Although I think yesterday I was actually looking at reading the specification. Let's see, would that be schema? Some, oh my goodness. Okay, so this is just a bunch of type definitions. This is the JSON schema. I guess I could probably just ask let's see what Copilot tells me. Give me an overview, but not too shallow. Rundown of the model context protocol. Specifications. The stuff and experience developer needs to know. To get up and running with building an MCP server. Relatively quickly. Let's see what this gives me. Maybe I should actually try to log to use. Oh, just noticed my camera is way off. Gosh, I always forget to do some basic. Well, not always. Sometimes I'm still doing the noob thing and forgetting to check my screen configuration to make sure that nothing wonky is going on. Apologize. Okay, here's what here's what it gives us. So it's a proposal for a standardized way of for applications to share contextual information, communication, the JSON RPC 2.0 messages to a server between host, client, blah blah blah. Key details, context and data for user. Oh yeah, model. So you have resources, you have prompts, tools, sampling. Sampling is not immediately obvious to me what that really means here. Utilities, you have configuration, progress tracking, cancellation, error reporting, and logging. So the usual configuration and just overall monitoring. Implementation guidelines, protocol layers, JSON RPC message types, lifecycle, initialization, negotiation, session control, server features, client features. Again, I'm not. Oh, I guess, okay. I guess sampling is really just, here's a pool of things, give me a selection from that pool that that are most relevant for a particular query. Root directory lists. That's interesting. Login and argument completion. Okay. Yeah, so there's a consent step whenever the model is trying to use DMCP server. Hosts must obtain a specific arbitrary code. So practical steps, ensure you have no above, blah blah blah. Schema management. Okay. I feel like that's mostly good enough. Oh. Wait, can I just I wanna see no. Oh yeah. Never mind. I thought he was going to just give me the same thing again, but from Claude's perspective. I do wanna see what Claude says. Oh. Okay. Can we do that again? Oof, that was fast. Oof, what is this? This has nothing to do with. Okay. Alright, that's not what I asked for at all. But I also don't wanna. I don't care to ask again, so whatever. Alright, let's look at the Python SDK. Let's see, I should just take a fork. MCP Python SDK. This is the Mali thing. Do I have this set up? Yeah, I do. Alright. Is there a readme? What's the readme? Nope. Can I preview this? No. Ouch. Why can't I preview it? Damn. Pretty sure I did that wrong. Yep. Okay, allows applications to provide context, blah blah blah, installation, UV add. Wait, so is my cursor broken? It wants me to update. It's just let's see, types. Oh my, anybody got time for that? Just a bunch of types. I don't think I need to go over that. What's by typed? Init. Ping requests, server capabilities, server notifications. Okay. Defining a session. And request context. So request ID. Meta none. Okay. Exceptions. Memory. Okay. Save the receiver and the sender stream. Okay. Okay. Yeah, what is NEIO? What's that? I don't think I've heard of that library before. Synchronous concurrency and that when it works on top of either trio or async.io. What does it actually bring to the table though? Okay, suppose it basically it's some sort of wrapper around some choice of async runtime. Like it gives you the flexibility of using either this or this. It's also incremental. Yeah, but why do you want this? What hypothesis? Oh, is it one of those, yeah, prop based testing? Too long. Let's come back. That was a little bit of a detour. Don't need to know much more than what I already know. So you invoke this and you get a client and a receiver. Okay, so it's some sort of channel thingy over some buffers. So the server gets its own channel and the client does too, and then you pair them up, right? So you have the server to client and client to server. pair them up like that. And then you basically just yield them. Alright, and okay. So you have a server. What is the type of that? I think we'll look into that later. Is cursor back? No, I think it expects me to manually open it. Tragic. Timeout. Sampling, callback. Login, callback, exceptions. Interesting. So if something goes wrong, you basically want this function to fail silently. So you open up a stream. So we read write. Task group, start soon. You run the server. I think there's this is all setup code. There's not much that is actually directly relating to the MCP spec. So I think for that maybe we need to jump right into the server. Gosh, this won't even open. Seriously? So you pay money for? Oh, I guess by you I mean me. Damn. See if I can open. Gosh, everything needs to be updated all the time now. So are we ready now? Open MCP. Okay, so init main. Oh yeah, I don't think I have. I guess which version of Python does this require? Yeah, no, well, yeah, I have. Yeah, sure, install it. I do have that. Okay, let's see the README. Is that a preview? Oh my goodness, this is horrible. Okay. so let's build servers that expose data and functionality to LLM applications in a standardized way. Expose data through resources. I feel like this is reminiscent of the Terraform system. Provide functionality through tools. Define interaction through prompts. So you name the server, dependencies. Oh, okay. These are not sequential. I mean, I guess maybe, but really only one of these will be what you will write. Lifespan. So providing some sort of context or scope, whatever, that will be available during the lifespan of the server. Yeah, and then you can retrieve it from the request context and do stuff. You annotate functions as being tools for resources. What's that about? Oh, it's a naming thing. Let's provide data but shouldn't perform significant computation or have side effects. This is some sort of identifier for the resource. Tools, blah blah blah. Client get. Okay, prompts. Okay. Straightforward. Anyway, base. Okay. It also has support for images. And the whole context then, I think oh, okay, you can actually access resources within the tools. And I guess, the context is the context for the overall. I think you have, it seems like you have request level context, but also the server level context. Okay. No, this keeps going. I thought we were almost at the end. Oh, wait. Lifespan SPI provides a way to initialize resources. When the server starts and cleans them up. When it stops, access to initialize resources through the request context in handlers. Type safe context passing between lifespan and request handlers. Okay. Alright. That's a decent readme. Helper types with resource contents. Right now we are looking at the server code and the low level folder. And here goes the server. Wait, let me see. I have right now can type wait. Okay. I am virtual if I think I should have, I think I have the right version. And let me see, what was the request? UV add. Wait, but I don't actually, do I actually want a CLI? No, I actually want, do they have something for development? Contributing, okay, here it is. Do I have UV? No. Give me a second. I need to figure out a quick command to like mute or something. Also, I need to make sure that my camera is not set to tracking. Alright, I'm back. Okay. So we have pip installed. UV installed. Okay. So I have that. I fuck the repo. UV sync. Choose the current branches for the changes. Don't plan on making any change at this moment, but let's just say have UV run PyTest just to see if all the tests are currently working. Alright, one skipped. SSE. Okay. UV run by right. Okay. UV run rough check. Alright. These are just, quick sanity check just to get a feel of, the repo and where things are. Because sometimes you'll have documents like this and, it's supposed to go like that where when you actually run the commands, you don't run into weird issues or bugs. But sometimes, the document is outdated or whatever. Okay. Alright, so now I think I was hoping this would be resolved. So this is imported but not used, but for some reason I don't have Pydantic. But wouldn't UV something handle that? Running this would not. Let's see. UV sync. Uh-oh. I have a feeling I was not supposed to do that. Maybe. Okay. Okay. I'm just gonna add it. I don't actually plan on committing whatever changes I'm making, so I just don't like seeing this. That's just a pet peeve of mine. UV add Pydantic. It is resolved now. No. Okay. Well, I don't know why it's doing that then. This could not be resolved. And I'm in the right environment. Oh, okay. So I just need to reselect it. I bet that's what I needed to do earlier as well. Anyway. So this is imported but not used. Carry over tab definition. Context variable. Context var. Where is that coming from? Okay, what is that guessing this is native to Python. Looking it up on the side here. Yeah, okay. I guess maybe I should look it up here. Okay. So you should use context aware instead of threading local to prevent the state from bleeding to other code unexpectedly. Alright. Okay. Alright. Notification options. So this is a configuration class. Oh, configuration object class. Okay. So default lifespan. Inherits from the lifespan result T. Okay. Version instructions. Why not make this a list of strings? That's what I would have done. Callable for the lifespan. And if I remember right, this is only called on initialization and on shutdown. Like it's not called on every request, I believe. Request handlers. A dictionary of, so you have a key and you have a bunch of callbacks. We don't really care about the arguments for the callback, but we know that it returns a server result and a promise. Okay, so void handlers. Stored out empty. So you have your request handlers, your notification handlers. What kind of notification again are we dealing with? When a resource changes, when a prompt changes, and a tools change. Okay. Alright. Create initialization options. Okay. Wait, but why is this an instance method? Oh, well, I guess if you want to reuse whatever information you get from here to spawn another server. Yeah, okay. Great capabilities. I mean, okay, this is strange of a parameter. You're trying to get the capabilities and yet you're passing in your own, which by the way is not optional, your own set of potential experimental capabilities. That seems strange. Set prompt capabilities if handler exists. Okay, so these are keys. Actually, I'm curious. Okay, literal request param. Space model. Okay. So if this is in the dictionary, then return that. Oh, okay. This is just a boolean. Okay. Wait, but is listing the resource? Is that the only resources capability? Yeah. I don't wanna spend too much time on this. It's just taking a survey of capabilities. It's strange though to pass this. I think this function shouldn't be responsible for this. I feel like the caller should be the one merging this into the response. Because this is literally just a pass through at this point. Yeah. And I mean, it's also a very trivial pass through. It's not doing any sort of merging at all. So I'm really not sure why this could not be done by the caller, and it has to be inflicted upon this method. Also, wouldn't you be using the notification options of the self, of the instance itself, instead of passing in this? And if you are passing in this, shouldn't, like, passing these two in here, my assumption would be that they're meant to act as some sort of overrides when you're merging the instances stuff with these parameters, but these are, there's no merging at all. Okay, that's a choice they made. Okay, request context. Makes sense. So these prompts, decorator. Excuse me. Okay, yeah. So it takes in a function, actually, yeah, a function meaning really a callback, which, well, really a promise. That returns a bunch of prompts. Okay. Same story here, except here you have some sort of identifier that is being passed. It's not immediately I guess some sort of key value options for the retrieval. Call the function with the name and the arguments. Okay, so we have list prompts, get prompt, list resources, list resource templates, read resource, none of this feels like just boilerplate stuff, which is fine. It's not that interesting. I forget that Python has a match keyboard now. I mean keyword now. I mean, I'm used to reading a lot of ROS code, so I'm used to it. Just anyway. So if it's text, return that. If it's a stream, a blob, whatever, do this. Excuse me. Wait, so, okay, so this was a util function. So based on the result of actually calling the callback on the promise, I think this would be the base case of just returning tests, right? Well, actually, it says also byte. Okay, so it's either a thing or it's a lot of things, and you just need to iterate through it. You need to filter the stuff that you're not interested in. Okay, set login level. Subscribing to a resource. I guess this is based on the notification stuff. Assuming an input URL. Scheme, pod, path, blah blah blah. Oh, this is just okay. But anyway, it's a resource identifier. Yeah. Subscribe. List tools. Call to progress notification. Provides completion. You have a callable. So either you have a prompt reference as an argument, or there are two arguments. You have the completion argument and some sort of reference. Okay, so you have completion. Alright. So this is the head honcho method here. Well, maybe there's other stuff at the bottom here, but run seems like the big boy. So you have a read stream and a write stream. Your initialization options. Okay, yeah. What's up with this? When false exceptions are returned as messages to the client. When true exceptions are raised, which will cause the server to shut down, but also make tracing exceptions much easier doing testing. Okay. Okay. So you're setting up a context here, the last one context. Task group for message in session incoming message. You log this. Start soon. Okay. Okay, you handle the messages like this. So you have the handler, the message, the session, everything here is context related stuff. Okay. Handle notification. It's funny, sometimes I forget that I'm recording this because I just go completely quiet trying to work some stuff out in my head, and then I realize there's actually a camera rolling and that maybe I shouldn't be so quiet. So there are two cases for the message. I don't know why. Yeah, Okay. I was zoning out into something else. This is straightforward. Um, so the handle message then calls the handle request. Okay. I mean, we do see this being referred to in other places. So on each request, we set and unset the context. And that's if we find a handler. If we don't, I feel like you could have done a early exit then. I mean, semantically it's the same program, but it would have been nice to just say, if this not in that, then do this, and then you don't need an else block. You just go on. So for notify, we just check that it's in the handlers. Wait, so this is an interesting thing here. I would just assume that David had a good reason to do this, but that is still strange. Because we should never be able to. There should never be a case where this fails, but this passes, right? But then I guess maybe there's a weird Python idiosyncrasy that you have to deal with here. But really, when you look at this, they really should. I mean, the second one is redundant, right? Okay, so that's the deep, low level server implementation. Pretty straightforward. I mean, list prompts, get prompt, list to, get to, run the server. Excuse me. Yeah, okay. That was the bulk of it. Models, prompts and tools. This is a very empty module here. Session. What's going on with SSE? Okay, so these are the different transports. So is fast MCP an implementation of the MCP? or ergonomic. Okay. Okay, so for standard IO, so here we are having communication via standard IO per the name. Standard in, standard out. Yeah, okay. Standard IO server. Encoding of stack streams on Python's platform dependent. So we will wrap the underlying binary stream to ensure UTF-8. Okay. What does this method do? Wrap an existing file as an asynchronous file. Okay. Text IO wrapper. So you have the buffer, the encoding, errors, new line. Basically how to pass a new line buffering right through. Yeah, okay. Yeah, alright. So you have the read stream writer, and the write stream reader. Okay. Oh, okay. Well, I guess. Okay. If there is an error, just send that error. Otherwise, just send a message back. Have some validation here. So for this one, we have the message, do a model dump. We just write that to the buffer, then you flush. Okay. Let's look at session. We change the server and the client. Frameworks most commonly used in should not be instantiated directly. Alright, so initialization state is either not in the process or initialized. It takes type parameters. Starts are not initialized. So you have the read, the write, and the init options. Calling the parent class. Base session. Client params. Check client capabilities. This is just one thing or multiple? Okay. So this is a basic check. So no client params, then exit early. So get the capabilities. I will go through those capabilities and see if there is a match. So when this is none, well, not none, okay. So there's a mismatch. The client is asking for something that the server doesn't have, so you return false. And obviously this, getting a notification for when a list changes. Anyway, this is pretty straightforward. Given a capability, look through all the known capabilities, and if it's not there, return a false. So when a request is received, you have the initialization. If it doesn't yield anything, then the likely issue is that requests are coming in while the server hasn't been initialized yet. It's gonna respond. Pom pom pom. Bum, bum, bum. Okay. Wait, but is that um okay, yes. Okay, in the case of initialization. I was about to say this feels very not what you need for actually handling requests, which is in fact basically we was lost there for a second. Um, okay, so this is for initialization. I don't know what the hell that's really about. That's okay. Oh, okay. Initialized. Send log message. Oh, okay. So it's not. Like sending it to some buffer or our external service. It's just to trigger the notification. Oh, wait, but there's another send notification. Okay, well, notification of messages. Excuse me. I keep sinking into my chair. Alright. So you're creating a message, your system prompt, your context, the temperature, there's a model parameters. This stuff here. This stuff. System prompt and max tokens. So here we're just sending a message. These routes, set a ping. Just send the request, Excuse me. Oh, I think no, okay, we did standard IO. Yeah. Okay, let's look at what's in fast MCP, but let's be picky. Oof. Big file. I am fading a little fast here. let's see if we can look at some of the no, it's not it. Some of the pull requests. There's no strict mode. What is the fix? Jesus. Okay. Don't know that this necessarily has anything to do with SPL. Doesn't look like it. All these are cosmetic changes. Hmm. Yeah, I mean, oh, okay. I mean, it is said pyrite. So this is really a cosmetic thing. Okay. Oh my, 600 lines of codes, but I mean, it's in draft, so. End-to-end tests. I don't know. I feel like this might be a little too early to start writing that stuff. Let's see the issues. Tools form sends an empty string after removing a field name. 4 hours ago. Tools that have write access should be handled more carefully than read-only tools. If the LLM selects the tool, the client handles the tool request and asks for user confirmation via the UI. Okay. Okay, so it sounds like this is something the client, well, this client has it and the backend doesn't yet. Excuse me. Yeah, I mean, this part here is probably why they're not going to pay much attention to it at this point. Oh, no reading all that. Unable to connect to MCP server. Hmm. Oh wait, there was something that I saved. Music. Where is it? Um, why can't I find it? Oh, damn it. Oh well. I'm doing something on the side here instead of looking at the code. Um, hmm. Anyway, I was looking for something, couldn't find it. Yeah. Now I'm bored. Don't know why, but I thought I would be more excited to look at this. Interesting that it's superfluous server to both. What does it mean? What do they mean by it doesn't support? Doesn't support it. Alright, so in the CLI, what are the commands? Run? No. Ugh. I think maybe I need this. like that. So there's one, and then there's two here. Well, no, I don't think this is what I want to see. I'm trying to. Okay, so you're importing the server. Said something about dependencies. So is it? Sounds like it's using the first. Yeah. There's the CLI is using the. Oh, but it doesn't say that here. Okay, fast MCP. UV, and then MCP run. MCP server app. Version. Okay, dev. So you're loading from the file spec. Loading the file. Wait, no, I left. You are responsible for ensuring all dependencies are available. think I've had my fill of MCP server code for now. And session receive loop, blah 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 blah. Yeah, okay. Maybe just quickly looking at the tests. Okay, so you're starting curious to see if it actually runs. Oh, what do you mean? Oh gosh, this is annoying. Tried playing that, but it wasn't working, so I don't know. Can I just do this? Nope. Still broken. And I don't care to do anything about it right now. Simple messages, yeah, right. Blah blah blah. Started in sick, so we return it back to the beginning after doing the writes, all these writes. Start on your server. You get your read stream and your write stream. Can you get messages from the read stream? You don't. Well, you may get some exceptions, and you need to raise those. Okay. This corresponds to the number of messages set up here. Probably could have done length and messages instead of 2, because these can easily become out of sync. Same idea here. Yeah, okay, this tests are straightforward. Okay, well, now I'm bored. I've heard of this library before. Hmm. Hmm. Okay. Number of tests. Okay. Do, 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 do. I feel like there's an agent framework every other hour now. Oh, the JFK files are out. 20 millions a month. Wow.
Well, and the scale stuff, like I'm a weirdo. I've actually used MyFitnessPal for probably 5 years, almost every day now.
Yeah.
And what a lot of people don't realize is when they eyeball their calories, they're probably always off by like 30 or 40%. Have you ever tried tracking your food, Sean?
Yeah, actually, I think you're saying
Does he talk like every 16-year-old? You sounded like this, right, Sean?
Which one works better?
Honestly, I thought that I always had this vision as a kid that I just need to be successful and all the girls will be on top of me all the time.
Why'd you decide to make that video?
Well, from such a young age, and I'm not entirely sure
Info. How many employees?
Totally. Right now, we have 15 employees. Disregarded anything from them because I always think it's biased.
Okay,
Smart.
so you can send it to them. They say, "Oh, it's great." You're like, "All right, cool," but we don't really know. Next, what'd you do? What'd you do next?
So next, we started contacting influencers, fitness influencers on Instagram and TikTok.
Did my DM get lost in the mail?
Okay.
This
Hi, well,
Legal satellite.
Today in this video, I'm going.
I do mean. I do mean this, that I love articles that are titled in such a way that make me think that I'm confirming my own bias, okay? Like, honestly, I am not somebody who believes in this idea of being able to be unbiased. Like, I recognize that we're all biased, and I just, sometimes I embrace it. So if this is all about students and the danger of AI, dude, I'm so excited because, the reality, just as warning, I think the reality is that there's about to be a lot of younger engineers that are just getting started. They're going to have the rudest awakening of their lifetime. And so if this article confirms my bias,
some of the common problems that they're trying to figure out is one, how do we advance our business using artificial intelligence now? Because it's all the rage, right? We've gone through all the different stages of going from monolithic apps to microservice-based applications. We're now talking about AI. So how do I leverage AI to one, improve my digital experience, reduce costs, improve my developer productivity, and that's what we're thinking about with regards to observability as well. How do we provide you insight in order to allow you to do those things and address new challenges that they're becoming very apparent within the observability landscape due to this kind of shift, right? So there's more demand. Services that you can grow without manually jumping screens, and so we made our first evolution of fixing that issue, providing you all of your data within a single pane of glass, so you can have context rich technology. Right, so we're thinking about the risks and drawbacks that we had, Leslie. Right, so the applications are coming with additional components like LLM, vector data stores, orchestration frameworks that you have to deal with, and so this added complexity is making it really hard. Biases, hallucinations, toxicity, managing costs, right, balancing the cost of your AI tool versus system performance, but also how to deal with this new security and compliance regulations that are so that single part of the transaction is going out to the LLM and the database. We're giving it to you in full context of that. Right? So within your location, we're not only showing you the performance of your application service, the underlying infrastructure, but we're also showing you the parts of recognizing that, okay, well, this transaction or this call is leveraging OpenAI or Claude. It's making a AI request. It's calling out to a vector data store. So now we're providing you that insight as well. How long did it take for the application to respond? How many tokens did it use? Was it an error rate? What was the response that a user got back from the service, and is it accurate? Right, showing you the complete trace, right, for your individual transaction, so you can see every step along the way and pinpoint bottlenecks or errors along the user journey. Allowing you to compare models, right? So which version of my LLM is performing the best from a cost standpoint, error standpoint, or response time. And also helping you address issues around compliance and security, being able to identify out of the box patterns like social security numbers, credit card numbers, and block that information to make sure you're protecting your users' PII. Right? When you put all these pieces together, it's taking what we thought about with regards to observability, starting to push that landscape forward. Other partners within the industry. So GitHub Copilot and New Relic can help you understand the deployment and provide you with insight on system health. So let's say you have a bad deployment, gives you a change report, it teaches you or tells you that you probably need to roll back, right?
I need to get back to my Kubernetes tutorial thing. I mean, reading through the manual thing. Gosh, this guy's thing is now everywhere now. I mean, isn't that the same person? Never mind. Looked like another one from that I saw up there. Oh man, these thumbnails, they're getting out of control.
Yeah, I was saying it's good stuff. You should fast. I get physically able to can.
Oh.
Just participating in that will need to.
Doug, I think.
I think we actual code. But yeah. So I do want to say it is just software. But I don't need to trigger this. I personally, this is my personal opinion. I think it's primitive. It's not every day that you get a new primitive in software. You know, at this fundamental level. And I think this primitive really is just a huge deal. I think it unlocks new kinds of software that you look for. It also completely changes how you're supposed to build software. And I'll explain why. I think this is the most exciting part for this community. Okay. When I show this is like a nice cool like here's what's actually going on. So it's actually going on. There's like a crazy person inside your code and it's calling functions. It's like, oh, we know this. Maybe we'll do that. And if you bought the expensive model, it'll probably be fine. If you buy the cheaper fast one, it's going to make a lot of mistakes. And so this is very, very new for developers, okay? Because developers are used to unpredictable, unreliable beings interacting with software from the outside, right? Have UI, have buttons. You know we're not going to click the button. You know we're going to click some random pixel on the side. You know we got the keys for this. You know, okay, well, I forgot to put a login here. Because there's another, non-authenticated thing somewhere that we're not supposed to access. Someone's going to find it. They're going to mess around. So you should close it, right? You just keep an app. You just kind of do it. Because what's the other source of unpredictability that developers are used to? Something goes wrong inside the system. Something unpredictable. Right? Now, what do we build for us here? Basically, survival methods, right? Resiliency. We're crazy inside the system. That's what fucking here is. So we got all these things. Oh, who cares? Just do format mapping. It's so beautiful. I'm going to put it in a box just in case you lock it down. Just in case it's something completely stupid, which I know it will. So here it is. It's in a box. That's essential when you're dealing with the unpredictable creative elements. Secret management, I mentioned tracing, observability. Why do you need to observe everything? They force you for it, right? Because we don't know everything's going to happen. Why? Because we don't know what we're going to code. We don't know what the person to do. If we get in advance, we just audit everything in advance and it'll be done. Like there's agents in software because all software will have components that happen to be existed. You can have like intelligence in your to take the tech you learn and make it available as a platform, as a sort of operating system. So I think there's going to be like a new platform building that's going to be very strong. And now, with the plan I have, I'm not sure exactly how it's headed. I don't know if they propose a choice. I think it's a safe version of this presentation, or whatever we'll call it. Community engineers. And what they do is because Dagger is looking for first principle, they go and apply it to other things that kind of look like a build, and they will benefit from the properties of Dagger. Part of that access is going to now, primable. So it's got an API, and then per that API, it dynamically run functions, and these functions produce immutable objects, like containers, directories, and then you call more functions to transform that further. And you're building a DAG of these states, right? And so kind of like a DAG, maybe you can define CICD, like YAML, or a bunch of build tools, but this DAG is dynamic, because making these API calls. It's all containerized, or hopefully, or CCI, everything's nice and portable, or some use containers. So that's Dagger. And so because it's an API, you can call it from code, you can pipe it to another function, and I'll say, from outline. And then I'll pipe it to another function. And I can notably give this all types right under the button, just like a fully typed discoverable API important for later. And I can say, with exec, think Docker file with API, roughly, okay? Add gifts, and then make the internal. Well, just going to do it. I did that before, add a container. If I exit the container, it's gone. So cache install terminal, and then again, I can say, oh wait, forgot to install SSH. Okay, cool. I didn't do that things before, so it's cached. I can add, let me add just a file, with me file. Hello, ICO, and this one that. Okay, and now you see it builds the same container that has this file. It says hi, civil navigate. You have this nice kind of rapid iteration loop. I mentioned I hate things going slow, so that's just like all Daggers like that. And then you just kind of construct a build, and then what people do Dagger normally is when they're like, yeah, I like this, and then they open their IDE, they open their IDE, and they'll go, they'll go somewhere in the repo, here on this wonderful repo called Cbo, and they'll go Dagger in it, install the Dagger module, they choose an SDK, go, because then we'll really put it back on the picture, and then they call this, initialize, create a bunch of files, we cancel for the before, and then you have this, cool file, here we go, there's a type, there's an example function, that's a module, so here I say, build, on the build function, let's say I would do exactly what I did before, which was this, so copy, okay, copy here, put in a comment, and then here I'll say, build cool container for SQL navigate. And okay, it's a build function for return to container, right? So I'm just going to use generate types to say it returns a Dagger container. That's a build function. And then same command I can make in Go using SDK. Here I'm going to try something. I'm going to say, there, check these. Transform to Go Dagger as a gate code. I think I'll have to figure it out now. Okay, so I'm vibe coding. That's vibe coding. So you can see that this is a nice native set of Go calls, but it's real Go, and you can add stuff like with new file. You can see it's all in there, all the bindings. It's the same API recognized, the same command before. So that's using Dagger. And then open the shell now. I'll just reload. Delay. Okay, so, and then I can just call, what do I call it? Build. Right. Oh wait, I'm in the wrong place. This is where I have to go. So it's going to load that module from print directory, or you can point at a Git repository, it also works. This is all containers. So if I push this, you get it now. You get the Dagger CLI, you run the same thing right away, which is nice for collaboration. Okay, build.
I feel like this is the third time that I've come across a talk from Dagger. It does seem like a pretty cool tool.
Secrets, we had all these primitives. We added Ella. So if I run Ella, I get an Ella. In this case, I get a GPT-4 endpoint, but it's a multi-model. We tried global models. They all use the same API anyway. So I have a new instance with Ella. The first thing we started is, oh man, can we get my Ella rates? LLMs work exactly like built. You got mutable states to context, and then anything you can do is a transformation from a mutable state to mutable state. You prompt, you message, you're building the LLM state. It's very cacheable. By the way, a huge trick that the LLM companies use is cache everything. It's just a build. So you can do something like you can add the state, you can add prompt. Okay, you can and then you can query, you get a history. This is in the API. Okay, and then Bob, so it's going to do answer. Oh, we have tracing built in, so you're looking at open tree trace of that. Your name is actually Bob. Okay, what do you say? And then I just want to show you chain prompts, what name did I give you? This is not impressive at all to me. There's like 1,000 ways to do this prompt. This is not supposed to be impressive by that. But it is cool if you're, for a DevOps engineer, using Dagger to build things now, access that primitive at any time. And it turns out that already is useful. Sounds cool, how like just prompting is useful. You've heard me Bob. Okay. So that's all. And what I do is I go and get my traces in their file, and I see my whole session. Or it's Eric do something. You also see those traces. Well, fun. It's fine. So it work. You can see my name's Bob. My name is actually Bob. So I picked up my resolution tree. Okay, cool. So I can do this here, and I'll go dag.ln. So I have the function like CI that is for the PR. It was in the box, and I asked, what do you think of this? Is this readable, or is it translated to French? Whatever. Okay, cool. Now the full call, that primitive. What I can do is maybe some function. I'm going to call it DevOps. And DevOps, ask the DevOps team to modify the container. Okay, so I'm going to give this argument the container, and a request. It's a string, right? And it's going to return a Dagger container. So what I'm going to do is I'm going to instantiate an element in my code. So I'm going to do first context, and then because it's all the APIs is discoverable, right? Any type that's available in the API, in this case container, you can connect to the element, you can make it available as an environment. Remember that? So just deploy it and say, hey, now you have a container. It's all typed, so give it a container. And then I'm going to prompt it and say, you are awesome. Okay, this is 90% of AI engineering. It's just like tweaking your prompts, right? So it's all caps. It looks better, it's all caps. No one knows why. You are an awesome DevOps engineer. Seriously, so cool. This is like plus 20% performance. Developer has to improve it out. You have access to a container. Modify it, please. Plus 10% performance. Please not. It's true. Please modify it. Please following description. Oh, this is just like a little, because I was tired of doing printf. I just added insert variable to the prompt. This is request. This is just what prompt access it. Okay. And then it's in that loop, right? And then I get the container back. And then I return. And that's it. So now we reload this. And the goal is to show, like, okay, for first principles, I'm not going to show you that in here. And rebuild that. Then we build Melvin. Like, fully version of that. That's fully the source. And maybe we want to so you can send it. What I call it? DevOps. All type, so, you know, I need to pass a container. Okay, so give it the result of, you know, so you can set pipeline, run pipeline, pass the result. So this is regular container outline. And, and then please install a bunch of stuff, a bunch of packages, whatever I need to develop in, what? PHP, basically. Excellent. PHP. Okay, the call, okay, get the prompt. Let's see if we can get this in, trace this in, cool. Let's see trace. Oh, no, let's start it, oh, yes, it. Okay, let me just look at trace what happens, it's happening too fast. Observability, what did the robot do? Okay, you're not an engineer, it is, okay, so here's what happened. I plugged this container object into this LLM, right? And so this primitive in Dagger, the Dagger system actually scans the API beyond it, all the functions available in it. It transforms it to the OpenAI protocol for tool calling. You know, exposes the function. So we call this the VBI, the body brain interface. It sounds cool. And then it's like, you know, you plug your brain into this body robot, and you turn it on. The brain's like, ooh, what do I have? I have an arm. I have, you know, okay, this takes off, cool. And then you get the request. Okay, let's see how to do this. And so here, try APK and actually messed up. This is happening. Okay, so now I'm gonna say, if you try, you can always succeed. This is very important. Okay, so as you can see, this does not solve the mystery that is the idea. But it, you know, the goal is to make it accessible, so we're actually getting ready to stuff that has an impact as opposed to glue. Let's try again. Come on, you do it. You did it 10 times before the demo. Log is reversing. You sure you had that? I'll eat all of these. Let's skip. Let's skip. Here we go. Oh, has been successfully installed. Okay. Cool. Let's all catch it. We're running get a terminal. Cool. PHP MS. PHP installed. Cool. Like, is it? I'm gonna say it's normal. That's like a PHP thing. Okay. Okay. The cool thing is, I'm gonna try and mess with it and say, okay, now it's Ubuntu. Now it's Ubuntu. We're gonna do now. Robot. Wait, it's interest. That's just too slow. Oh yeah. Okay. So that's good. This is what I was hoping to show. It's trying to I don't know why it starts with APK. Overtraining on the Docker stack, I guess. It's trying APK. Oh, sorry. No, it's trying APK. And it failed. It got the error back. And then it was like, oh, they need to do it. And it tried to get that. That's the negative feedback, right? So if you model and give it the right set of tools, it gives us enough constraints, then you get this and figure it out. And it's like, okay, then if you get it is, okay, it's, you know, I did it. So that's the idea, right? Okay, so that time I'm gonna try more. We'll try to build up. Let's see how far I can build up. But picture the methodology here. We've been having this. The way people build agents today, the state of the art is big, complicated monolith. Got a lot of Python, usually some TypeScript sometimes. It's a big monolith. You got prompts, you got tools, just like blah. And then it needs to be more powerful, so you add more and more. And then we've seen that move before. But a lot of people building have it, so the approach thing this is like these cool modules, like micro agents. Like, sometimes there's agentic ability in the components. Sometimes there is. It's software. Okay.
All right. Let's see.
So throughout this talk, we're going to do kind of three main things. So I'm going to give you first an introduction to who 11 Labs are and why I'm here. I'm then going to give a quick introduction to voice agents and the advent of voice and AI and what that can achieve. And then we're going to talk about, we're going to show you how ontology can power deeply powerful and intelligent agents that can interact with users to solve problems through voice and through conversation. So to give you a quick introduction about 11 Labs, for those that haven't heard of us, so 11 Labs are an AI research company and audio product company. So we build foundational generative AI models in the audio space with a mission of making content accessible across multiple languages through voice. So we're a relatively young company, like most generative AI companies are. We were founded in 2022, but it's the 11 Labs platform. And it's kind of like our first kind of basic building block for working with AI in the audio world. And so this is a text-to-speech interface. So what I can do here is I'm going to show you one of our foundational models that we've built for converting text into voice. And hopefully you'll agree it sounds pretty human-like. And if you compare it to the kind of answer machine robots of kind of pre-gen AI, you'll notice a significant difference. So I'm going to go ahead and enter some text. This is DEF CON, so an epic movie trailer voice feels appropriate. And this is one of the voices we have on our platform that we've generated by working with voice artists. And we're going to generate some audio.
Hi everyone, it's so great to be here at DEF CON. Well, I'm not really here. I'm AI, so I'm not really anywhere. My voice has been generated using one of 11 Labs' cutting-edge AI models. Notice how epic my voice sounds. I can pause and, well, I can also speak Spanish. Hola a todos. Puedo hablar muchos idiomas diferentes.
So hopefully you'll agree that sounds pretty good, and there are a few things that go into that. So firstly, our model is able to detect the context of what is being said, as opposed to just having a set of rules for how to say particular words or vowels. So what that means is it can insert pauses where appropriate, it can insert breaths where it needs to, and it can pronounce words based on the context, so it can say read or read, giving you support from down the road. Your region and exactly what you'd expect. If you're looking at promotional content, you can have a voice that sounds very Hollywood and very polished, and we're trying to build exactly this. If I want to, I can pick on any of the LLM providers or a fine-tuned LLM that I kind of have available myself, and then select the all-in-one voice. And what the LLM platform does is it stitches together the LLM of choice, our voice models for voice agents. Hello, can
That's
you
an
hear me?
awesome project. Yes.
So I think what's happening here is that the AV is picking up an echo of what I'm saying, what the laptop as it's saying.
Audio.
That's fantastic.
That's a great. Hi, I'm Eric. It's great to be at DevCon. What are you planning to build?
Hi, Eric. I'm planning to build a voice agent.
That's awesome. I'm a big fan of voice agents. What kind of voice agent are you building? What's the purpose of it?
I think it's something for support.
That's a great idea. Support agents can really help customers. What kind of support are you thinking of? Is it for a specific product or service?
I think I'm more interested in how to build it. I'm a developer after all.
Of course. It's always good to get a solid understanding of the technology before diving into a project. What are you most curious about? Are you thinking about using a specific platform or programming language?
Yeah, I want to use 11 Labs conversational AI.
That's a great choice. 11 Labs is a powerful platform for building conversation.
Can you tell me what are the languages that you have SDKs for the 11 Labs conversational AI product?
You're right. I got carried away. I'm still learning about all the different tools out there. I'm not familiar with the 11 Labs conversational AI product or its SDKs. I'm still under development, so I don't have access to that kind of information yet. However, I can help you find the information you need. Do you know where I can find the 11 Labs documentation? Maybe we can look at their website together.
That's not very useful. Thanks, though.
I understand your frustration. I'm still learning, and I'm not able to help you with that specific question. I'm working on getting better at finding information.
What I'm saying.
Yeah, the thing that's still annoying with voice agents is when they try to recover slash what's the word, overcompensate in somehow, and that just obviously makes it feel like, okay, a real person wouldn't actually say those things, which I guess is fine, right?
Because we built these models from scratch to really have low latency, and we spent a lot of time orchestrating the plumbing between them, all of these kind of array of audio models. The other thing you probably noticed is that it wasn't very useful. It wasn't actually able to answer my question. And so one of the things that is no surprise to anybody in this room is that one of the most important things when working with LLMs is you need to be able to give context on your end. So here what we can do is we can actually start to feed the agent information about my enterprise, my business, my products, by uploading files or by pointing it to public documentation that it can kind of scrape that information from. So here I'm adding a document from our public doc page. And in fact, kind of skip to the kind of the end product. We've actually done this already. And so this is our in production user documentation for our platform, our website. And you see in the bottom right-hand corner, we have a widget, which is our conversational AI widget. And so let's go and try having the same conversation I had with my kind of naive three-sentence off-the-shelf LLM, but now with who we call Alexis, who is currently on our website in production answering hundreds of user queries every day.
Hi, this is Alexis from 11 Lab Support. How can I help you today?
Hey, Alexis. I want to create a voice agent using conversational AI. Can you tell me how I do that?
To create a voice agent using 11 Labs' conversational AI, you can start by exploring our documentation on deploying customized voice agents. This will guide you through setting up your agent, integrating it with various platforms.
A specific question. Do you have a Python SDK?
Yes, 11 Labs offers a Python SDK for deploying customized interactive voice agents. This SDK will help you build your voice agent efficiently.
That sounds great.
Would you like
to show me how to use it? Can you show me the docs?
I've directed you to the documentation for the Python SDK. There you'll find detailed instructions on how to use it for creating voice agents. If you have any more questions, feel free to ask.
No, that's everything. Thanks so much.
Okay, so what you can see here is I need to have an understanding of our products and what SDKs are available.
That's why some of these demos, though, it's like the most basic shit that it's like, okay, you can navigate me to a page in it. I mean, I guess you gotta put things into perspective. 5, 6, 7 years ago, we weren't doing this, so. But still.
Because it's got that knowledge base, it's also able to interact with the user's browser and the client. And some of the things I didn't show you is it's also able to interact with external systems to make API calls during the conversation to fetch real-time information, real-time data. So moving back to the slides, what I showed very quickly was a couple of things. So firstly, I showed you that AI models for generating voice, how great they sound, how strong a variety of voices there are so that you can use those for whatever content you're trying to create. Secondly, I showed you it's now really, really with our voice setup.
In the healthcare industry, where it's like patient scheduling workflows and even just general customer service workflows. So traditional non-voice solutions today often fall short and lead to suboptimal user experiences. And while voice agents by themselves can't solve these problems, by having Foundry as the backbone to these voice agents, we can inject the right context from the different industries and domain knowledge, also provide historical context, and also even give feedback so that the voice agent can continuously learn and become more tailored to your specific use case. So because Foundry already houses your operational workflows in its platform, it's a lot easier to extend and add voice agents and voice tech on top of your use cases. So diving a bit deeper into the architecture, we start off with Foundry, which has a context in the ontology, and this is sent over to the 11 Labs agent so that it's well informed for when it actually has to talk to your users. Foundry also houses your operational workflows and permissions so that all actions taken in your platform are secure. The automations in Foundry are what can actually trigger the phone calls without needing a human in the loop at every step of the way. And this calls out to Twilio that handles the phone call orchestration, which is called from Foundry through a webhook out to Twilio. During the actual phone call, we add the 11 Labs agent to the call, and again, because it has the ontology context, it's able to answer the users in a useful way. After the phone call finishes, then we can send back the phone call context to Foundry into the ontology for historical record keeping, and also you can use the AIP toolkit and things such as evals to make sure that the voice agent can basically improve over time and become more tailored to your use case. So without further ado, I'll hand it over to Jake to show this implementation in action.
Awesome, thanks, Ellen. Let me switch to the screen. Sorry, this page. Okay, yeah. So now I'm going to walk you through a potential use case for building a Palantir for hospital operations. So every day we see that hospitals lose countless hours to administrative tasks that should be automated. So imagine I work at a hospital, and it's my responsibility to make sure that everything's in order for our upcoming procedures. On the left-hand side of my dashboard, you'll see a list of procedures that need my attention. So if we take a look at Anna Grant's upcoming cholesterol test, and I'll try to zoom in, you'll see that her prior authorization status is still pending. And since this is time sensitive, this would I usually have to call the insurance provider myself and sit on hold for what feels like forever just to get a simple approval. So what if I could have an AI voice agent call for me? Well, for me as a human to make this call, I would need the details about the patient and the procedure so I can answer any questions that come up on the call that the insurance provider might ask me. And the same goes for an AI agent. So because all these details are already available in my ontology, I can easily inject these as context into my agent before putting them on the phone. So you can see how I can plug the context into a first message in a system prompt where I task the agent to return me an authorization number and the approved date range. So let's give it a try. Another ambitious live demo. So in practice, you can trigger these off automatically, but for the sake of the demo, I'll click it manually. When I click this button, the AI agent will call on behalf of the hospital, and I will play the role of the insurance provider. Call. So my phone is ringing for proof. This is live. Sorry. Sorry. I'm gonna make him repeat that. Sorry, I didn't hear you. Can you please repeat that?
Hello, I'm calling to obtain prior authorization for patient Anna Grant with member number 5.
No.
Yeah, thank you for your time.
As I told it, 1, 2, 3. And then the approved date range is here as well. And so this is actually extracted from the raw text transcript that we get back from Eleven Labs as soon as the call completes. In addition to these details that we're extracting, we're also running some evals on the transcript to determine whether the user was happy and whether the agent was able to answer all the user's questions on the call. We can use these evals to continually improve our user's performance over time, and so that we can make sure we're finding the right details and make sure we're refining our prompt appropriately. And so in the case where the agent isn't able to obtain prior authorization, we can have the agent provide a summary of the next steps that a human would need to take in order to get this done. So my Zoom is a little weird, but in this case, it looks like the patient's information was not found in the system. And in this case, it looks like they want us to send a full authorization packet to their office email address. And so the other
Oh no.
to obtain prior authorization, we can have the agent provide a summary of the next steps that a human would need to take in order to get this done. So my Zoom is a little weird, but in this case, it looks like the patient's information was not found in the system. And in this case, it looks like they want us to send a full authorization packet to their office email address. And so the other important thing here is that for these failures, we're also writing these back into our ontology.
All right, I'm really excited about these next two sessions because they go hand in hand. First, we're going to learn a little bit more about some of the new capabilities in agents and how they make it even easier.
Still not the right. This is the right one.
All right. For this next product launch session, we've already heard this alluded to a little bit with some of the questions earlier. We want to be in the places where decisions are actually happening. Now, as a developer, I would love to think of everything as running on localhost or whatever the easiest copy and pastable tutorial is on the easiest setup page, but that isn't the reality if you want to go and actually do workflows in production and do meaningful automation. So we want to be able to give you the tools to be able to build for your workflows at the places where you need them. And to find out more about how we can do that, here's Luke. Hi, everybody. Nice to meet you. I'm Luke. I am a tech lead and product manager here at Palantir, and I'm excited to chat with you all a bit today about some of our most recent product investments at the edge. First off, I just want to level set with what I mean when I'm referring to the edge. Generally, I'm talking about small form factor, low power, generally disconnected devices, the types of things that you see on the table here, your Raspberry Pis, your trucks. That one's not real though. But the types of devices that aren't inside of the cloud, the compute that extends beyond that cloud's reach. And deploying and developing software for the edge it's a hard problem. And I don't need to tell a room full of people who solve hard problems for a living that, well, they can kind of be a massive pain in the ass. And I think this is for a lot of reasons. But one of the biggest reasons is how hard problems fly in face of our assumptions. And as an industry, we've made one rather large assumption, and it's that of cloud connectivity. Now, as with most assumptions, this makes sense entirely at face value. The cloud has been this incredible force multiplier that has entirely changed the way in which we build and do our business. But at the same time, over the years of embedding with customers, many of the folks in this room, it's become apparent that in a world that's ever building towards the cloud, so many of our hardest problems exist at the edge. Whether it's at Panasonic, these might be old slides, it's okay. Whether it's at Panasonic on the factory floor, where battery production requires millisecond level latency and bandwidth constraints, can prohibit the use of cloud infrastructure. Whether it's with our partners through the Warp Speed Progress program that is revitalizing the American industrial base and bringing legacy hardware investments online. All the way to our work with the warfighter, the DoD, where connectivity can be sporadic, but the challenges of war are anything but. So how do we, as a room full of builders, tackle this class of problems? And importantly, what can Palantir do to help along the way? I think, as always, we should provide some good tools, and what better tool to start with than the one that kind of started it all, the ontology. So with that, I'm incredibly excited to introduce the embedded
It's all about the
The embedded
ontology.
is a lightweight hosting infrastructure capable of running the Foundry ontology object system on nearly any device, enabling the creation of decentralized applications that can connect users across a mesh of different hardware architectures, all while interoperating seamlessly with core Foundry infrastructure in the cloud when online. Now, you might be wondering why we actually care about running the ontology at the edge. And I think there are a lot of reasons, but I'm going to focus on three. We have some demos to boot. The first is how it enables us to build these decentralized workflows and connect users through synchronizing their ontologies across a mesh of compute. The second is how it lets those users leverage the existing hardware, the existing devices that they already have in their ecosystem, even when they might be disconnected. And the third is how it allows us to slightly reframe the way in which we think about the ontology, turning it into an API layer for our physical world. But with that, let's dive into some demos. If we can jump over to my laptop, and we'll look at decentralized workflows. And also, if we happen to have the other slide deck, we can load it right now. Awesome. As a raise of hands, how many of the folks in here are backend oriented? Okay, so you understand why I can't create pretty front ends. This is our OSDK application, and what you'll see is a copy of two of the exact same applications. The one on your left is just a standard OSDK app that's deployed in a normal Foundry environment. So normal ontology indexed in the Foundry ontology object system, and then a self-hosted OSDK app. And this OSDK app is stupid simple. It allows me to create these check-in points on a map, so we can jump in and create a new one. We'll say something along the lines of hello from DevCon. We'll create that, and this just calls the action inside the pre-generated OSDK TypeScript bindings and actually creates an object in the ontology, which I can then go ahead and look at. Now, the application on the right is the same exact code, same exact application, but instead it's running on this Raspberry Pi right here. This is just a Raspberry Pi 5 that's connected to a battery pack and a router that's connecting it to our VPN. But importantly, we have the entire OSDK app as well as a full implementation of the Foundry object system running on board, meaning we can deploy this OSDK app to that Raspberry Pi with 0 changes required in the code. And because, like I said, we're currently connected, the ontologies between these 2 points in our mesh, the Raspberry Pi and our cloud ecosystem, are synchronizing automatically in the background. So I can jump over to the local host version and refresh, and you will see the object that we created. And of course, this is bidirectional. It's not just pushing down changes to the edge. This is still a fully functional application. So we'll say hello from edge. We'll create that here. And what's happening in the background is another new product that we're coming out with. We refer to it as Foundry Object Peering. And again, it's the way in which we synchronize these disconnected ontologies, these ontologies that exist on other form factors throughout a mesh, and allows us to create these collaborative workflows that tie together users who are on different points of compute to be able to work together seamlessly, even if they might be interfacing with different devices. Now, judging by people's faces, I would say like 30% of you are like freaking jazzed right now. Like you think this is really, like you definitely do, but you work there, Joe, so that doesn't count. The rest of you are probably thinking something along the lines of, this is great. I don't have a closet full of edge devices to make a mesh with, and I hear you. I understand you should try it. It's a lot of fun, and they're relatively cheap. But you probably do have one of these, just a standard phone. And this kind of gets to the second design principle that we targeted when building the embedded ontology. And it's this idea that we want our customers, the folks using this, to be able to leverage the investments that they've already made, to be able to leverage the devices that they already have in their field. And so I have a quick demonstration here that's actually going to be looking at a bit of a disconnected workflow that's powered by an Android OSDK app running embedded ontology. So let me pull up this workshop here. You can see this one looks way better because it's workshop and it makes things easy. But the story here is I am a technician that's deployed out into the field to do asset management. So I have assets all around the world, and I need to go in, inspect them, collect information, report different problems, and then sync those back into my downstream ontology and Foundry ecosystem such that they can be properly triaged, maintenance technicians can be dispatched to the area. Now, importantly, these assets exist in the field. The field is not near the cloud, and it's rather disconnected. And so when I go out there, I'm not going to have access to the same cloud infrastructure that I'm used to. So I'm going to bring with me an application. Let me jump into Android Studio here. We are back in the world of not as pretty UIs, but it's very functional. And this application allows me to do a very simple workflow. I can document different information about the asset and then sync it back for triaging such that work can be executed downstream. Now, like I said, we're in the field. We do not have connectivity. So I'm going to simulate that by just disconnecting from the Wi-Fi on the phone right here. So you can see in the top left, we are in fact offline. So I'm going to go ahead and just take a photo. You don't want that. You do want this. Go ahead and take a photo of the truck. Does that work? That's fine. And we'll report some sort of issue. The truck, seriously, is broken. And then we'll give it an asset ID because I need one. We'll go ahead and submit. Now, as you see, that submission was reported as successful, but we're also offline. So what's happening here? Again, we're running the entire ontology just on the phone. So that submission was successful. That application, that Android application that's running on the phone, was using just OSDK to write to a completely local ontology, and thus the workflow succeeded. And you can imagine extrapolating this out to much more complex workflows. Anything you can build with the ontology and the OSDK can be run entirely disconnected. But this information isn't now just locked down at the edge. It's not traditional edge investment where you pour a bunch of money in and all your data is now locked into a portion of your enterprise that you can't access. This is still just the ontology, and it's made to interoperate with our cloud ecosystem. So I can go ahead and just reconnect to the Wi-Fi. And what you'll see is, after a second, we boot online, and the Foundry Object Peering is going to synchronize in the background, and I can jump back over to my cloud workshop, and you'll see that the task is automatically synchronized with my beautiful picture of a broken truck. So this will now go through the normal process and resynchronize and go through any downstream applications
So this
inside my
is
cloud
just
ecosystem, effectively
local
connecting my operations at
first.
the edge. Oh boy. Okay, so remember that thing that we had with evals where you can make sure that your elements don't hallucinate? I'm not using that, and so the truck has a flat tire on the front left side, which is completely deflated. It's on the side of the road in a rural area. Wow, this is really, really a problem, and we'll have to take care of it. But you can see how we can connect our operations in the cloud and at the edge, enabling these workflows to stay connected, even if the individual users are not at any point in time, really bringing more capabilities to places that the ontology hasn't got before. Now, finally, I'd like to chat a bit through the third way I think about the embedded ontology. And this one's a bit more abstract, so bear with me. We generally talk about the ontology as a digital twin. You know, it's the nouns and the verbs of your organization. It's the API layer that you can interact with in the digital world. I've always felt that the ontology was particularly compelling when it was used to model reality, the physical world, the tangible assets that I can point to in a room, the things that manifest physically, your phones, your trucks, your drones, your pies, whatever it might be. And not only what they are, but what they can do, the actions they can take, the way in which I can leverage them, the way they interact with their environment. So when you take this class of assets that almost lends itself to be modeled by the ontology, and you pair that with the fact that we can now deploy the ontology incredibly close to or even on the asset itself, well, it allows the ontology to go from just being a digital twin to these style of assets to functionally being these assets, being their API layer. And this allows you to expose them through anything that's ontology aware, whether it's your workshops, whether it's your OSDK apps, whether it's your AI agents, effectively giving them a portal to the physical world. Now, I understand I just said a bunch of nonsense, so we're going to look at another demo right here. And this is the one that will probably work. I have a camera that is sitting on a roof somewhere, allegedly, and I would like to interact with it through Palantir, through the ontology. So again, like I said, I'm going to model it in the way that I think about it in the real world. I have the camera itself, and it's meaningful to me. It's a real thing. So I'll give some properties on it. It's got a location, latitude, longitude, a model, a serial number. But then it's not just the thing. It's what I can do with it. And this particular camera is excellent at.
By the way, this. I mean, the whole point of the ontology, like you said, is to. I think the catchphrase that I heard from the CEO was, "Your business as code, your business as software," and really comes down to being able to simulate the real world, and being able to just simulate different actions. So really, it's on a fundamental level, what they're trying to do is build a simulation engine. Now, the better it gets, the more incredible it can be, for better or worse. Right. But yeah, I mean, it's basically a simulation engine. It's literally basically like a game engine, right? You have your entities, you have the components, and you have the system. Like, if you want to think of it in terms of the game loop and the ECS system, entity component system, basically, you figure out a way to encode all your business processes as objects, links, and actions. And that basically allows you to get this really what's the word I'm looking for? This no, not that word. I was gonna say panoramic. I guess that could apply. Panoramic view of your business, and if you do it well, then it's easy for automation, right? And especially when you bring AI agents into the mix, because now they can really see how everything connects together, the kind of actions you can take, and the expected output from those actions, and so on.
Panning and tilting and zooming. And so I will encode that into my ontology API layer through a PTZ coordinate task. And this essentially gives me the ability to hand the camera a geolocation, and it will point to it. Now from here, I can generate just your standard OSDK app, and I can take that ontology and deploy it out to something that's connected to the device. Now, in this case, this is just going to be on my laptop because I have a network connection to the device. But I just implemented like a stupid simple application that feeds telemetry from the camera, its connectivity status, things like that, as well as listens for the creation of these objects running on board. So I can go ahead and just run this script here. Did my terminal bug out? I think it's working, things are just freaking out. Go ahead and run this here. And like I said, this is just the ontology, and it's the embedded ontology. So of course I can interact with this entirely locally, but I also want to showcase how this is just the ontology under the hood. We can interact with it in the ways that we always use the ontology. So I can jump into something like just a normal workshop application, and using all of our pre-built-in widgets, just drop the camera object directly on board. So you can see it renders here on the building that it's hypothetically placed on, and I can go to something that's recognizable, like this weird pointy building, and using just the built-in map widget inside of workshop, go ahead and find my coordinate tasking application, and assuming our network latency isn't super bad, that action should apply, and we should see the camera actually move in real. Oh, you've got to be kidding me. Seriously? Let me check. Oh, okay. Unfortunately, I'm running through about 7 network hops, and so we're going to see if this is actually going to work for us. There we go. All right, so rerunning it, we picked up the ontology object that I created cloud side. It's synchronized through Foundry peering to my laptop to the code that's running on my device, was then passed to the camera's driver and actuated fully through the ontology, essentially connecting the physical world with all of its cloud counterparts. And we don't want to just stop here. The idea is that we want to push the ontology everywhere it's needed. I think Chad tweeted this morning that the ontology is everywhere. We're taking that seriously. We're actively developing to push the ontology to microcontrollers, the chips that exist in infrastructure all around the world, hoping to bridge the divide between the physical and the digital world, and importantly expose it to our builders. So I'm very excited with that. We are introducing a private beta of all of this work, and are actively looking for people to partner with. So if you have questions, you have ideas, you have use cases, just let me know. Thank you very much.
Ontology SDK. Is that on GitHub? It really doesn't say. Compute modules. Deontology. Every decision can be broken down into data, logic, and actions. Yep. How does this? Need to do more reading on that. Actually, so much to explore, so very little time. So what did we do this evening? We spent some time looking at the MCP server, model context protocol. We have an idea of what the code looks like, and I think next time I'll probably look at more server implementations. I think yesterday we looked at one, I think, if I recall right. So between, I think, tomorrow and Friday, I may look at more of them. Yeah, I mean, other than that, I think I also have, like I said earlier, I think I need to get back to my Kubernetes, reading the manual stuff, and if not this week, then next week. I also, I think, want to set up I don't know if I'll do that next week. Depends on how things go at work. Set up a TLA plus. Yeah. I think I wanna start doing some exploration on when by exploration I mean actually sit down and write, because I've read some TLA plus before, so it's not entirely alien to me. There are several languages that are, specification oriented that I've been meaning to look into, and I feel like doing so now is probably a good idea. Just because of the way AI is advancing. I think program synthesis is gonna still making big progress overall, and part of it will involve being able to sketch or provide some sort of sketch of the program that is desired, and working with an LLM to actually generate the implementation of the program. I think that's going to start becoming a thing that actually is viable. So anyway, something to ponder. Anyway, I think this is it for tonight. This actually went on longer than I expected. Almost 2 hours and a half. But yeah, thank you for joining me, and I'll see you around.